Okay, so this is a quick review. So suppose on test 2, you're asked to solve this problem. And I'm making this up. All right. So now, what kind of inequality is this? Well, I want you to be a little bit more specific than that. Compound, thank you. It's a compound inequality. And if you notice this particular compound inequality, what's the idea in terms of x? Where?
In the center.
In the center. And so if this part wasn't there, then it would be a simple inequality. And so basically on test 2, when you solve this, you added 1 to both sides, and then you either multiply both sides by 5 and then divide it by 2 to get x by itself. Same thing here. It will be a simple inequality. But this is a compound inequality. So you do the same thing. You would do what first? Add 1 to all parts. Then you combine like terms. What's negative 3 plus 1? It's less than 2/5 x. This is 0. It's less than or equal to 7. All right. And then the next thing you can do, probably the easiest thing to do next, is to multiply both sides by the LCD. What's the LCD? And I said both sides, I mean all 3 parts. So you say times 5, and then times 5. 5 times negative 2 is less than, these 5's divide out, 2x is less than or equal to 35. And then the next step, divide all 3 parts by 2, and you found the solutions to the original problem. So the solution to the original problem will be any real number that's between negative 5 and, what's that? No, not 2.5.
35.
That's 35, right? So 17.5. Okay, so that would be my solution. So the solutions would be the solution to the original problem. So remember, you want to find the solutions of this inequality here, this compound inequality. Well, it's any number that's between negative 5 and 17.5.
And so where do we get the 2 that's underneath, like the negative 10 and
The 2 that's from here, you divide both sides by 2 to get x by itself. Coefficient is 2. You divide.
I was still stuck at the where we did the 5, 5, and 5.
Well, you got to get rid of the denominator. So you multiply all parts by the denominator by 5. Okay. All right. And then in terms of the interval notation, what would the interval notation be? Remember, is negative 5 a solution or not a solution? It's not a solution because there's no equal sign. Is 17.5 a solution or not a solution? It is a solution because there's an equal sign. Parentheses negative 5 to what? 17.5 bracket. Okay. All right. So that's something that I'm going to just slide it up. Okay, so then we start talking about graphing. And so if I asked you to graph y equals negative 2/3 x plus 5, let's say, using a t-table. Now, remember, this is a linear equation in how many variables? 2. How many solutions does this linear equation in 2 variables have? An infinite number. So just like with inequalities, you can't physically list the solutions finitely. We used a graph. So to graph the solutions, what does the graph look like? What's the graph of this equation? No, it's not a square. It's a line. Linear equation, right? And the word linear is what word? Line. To graph a line, how many points do you need? 2. But we use how many? 3 to make sure that our 2 points are correct, because they all have to lie in the same line. Okay. A safety point. Okay. This is a fraction, though. Last class period, what did we mention about some nice numbers to use for x?
That'll divide into the numerator.
The denominator. 3 is in the denominator. So you want to pick numbers that are divisible by the denominator. So what numbers are divisible by 3? 0. What else? 3. What else? -3. What else? 6. -6, and so on. Those are numbers you want to use when you have a fraction for the coefficient of x. Because if you don't use numbers divisible by this denominator, you're going to end up with fractions as your y value. So you want integers as your y value. So if x is 0, how do I find the y value? Wherever you see the variable x, what do you plug in? 0. So I get y equals -2/3 times 0 plus 5. -2/3 times 0 is 0. 0 plus 5 is 5. See, I got an integer from a y value. If x is 3, I get y equals -2/3 times 3 plus 5. And remember, the whole purpose of multiplying by a number divisible by 3 is so this number down here becomes a what? A 1. 3 into 3 is 1. 3 into 3 is 1. What? And remember last class period, I circled this because that's a product. What is this product right here? What's -2 plus 5? +3. So I found another solution. So far, how many solutions have I found on this for this equation? 2. These ordered pairs. Remember the word ordered pair. So if you went here, I need you to go and get those notes and look at the video from the class period, because all those terminology is in there. So I found 3 solutions. These are the ordered pairs. Now let's remember, we need just one more to use as a safety net. If x is -3, I got y equals -2/3 times a -3 plus 5. Remember, the whole purpose of multiplying by using an x value that's divisible by this denominator is so this number then here becomes a 1, and I don't have to deal with fractions. 3 into 3 is 1. 3 to -3 is -1. And so this product right here becomes what? +2. 2 plus 5 is 7. Once you find your 3 ordered pairs, you plot them. Now, so I plot the point 0, 5. Where is 0, 5 located? We talked about quadrants and we talked about axes. Is 0, 5 located in a quadrant? No. It lies on an axis. Which axis is 0, 5? The y. Okay? So 0, 5, remember, points to the coordinate plane. In a coordinate plane is divided into 4 quadrants. 1, 2, 3, 4. A point will either lie in a quadrant or on an axis. To plot a point, where do you start? At the origin. The origin is where the x and the y axis intersect. What are the coordinates of the origin? 0, 0. Good. When plotting a point, you start at the origin. I want to plot the point 0, 5. Well, x coordinate 0. Do I move right, left, or stay? I stay because x is 0. The y coordinate is a +5. Since it's positive, I go where? Up 5. So there's the point 0, 5. Now, if it says label, which your worksheet did say label that you picked up, what does that mean?
You would put beside the point.
you would put the coordinates listed. You would say this is 0, 5. Okay? Let's plot the point 3, 3. In what quadrant or axis is 3, 3? Quadrant 1. So since x is positive 3, I'll go to the right 3. And since y is positive 3, I'll go up 3. So there's the point 3, 3. I think just go ahead and leave it open because there's no noise out there anymore. Negative 3, 7. In what quadrant is negative 3, 7 located? Quadrant 2. Since x is negative 3, I go where? To the left 3. And since y is a positive 7, I go up 7. So here's the point, negative 3, 7. And labeling means to do what I just did right here. That's labeling. Now, what some students do, because on the test, that you're a little bit more stressed out because there's a time limit. Sometimes they'll do this. If I said graph the line, they'll do this. Is that correct?
No.
No. All you've done was indicate how many solutions? 3. How many solutions does this line have? An infinite number. So what is it supposed to indicate to me? You have to draw a line. So you draw a line with arrows, right? Okay. So you would do this. Now, remember, these 3 points are supposed to be collinear. They're supposed to lie in the same line. And so there's your graph. When we get into section 4, where we're going to talk about slope, you're going to notice that, see, when and we talked about this last class period in terms of falling and rising. As I went from left to right, this graph fell, right? That has something to do with slope. We're going to talk about that today as well. We're going to talk about slope. Last class period, we had some lines that rose. We're going to that has to do with slope as well. Okay? All right. So that's the graph of that one. Now, one of the so your solutions are located where? Where are your solutions located? No. Where in the plane is this? On the line. Okay, the solution is located on the line. So any other point is or is not a solution. Is not. The solutions are only located where? On the line. Okay. All right. So when you're graphing a line, you're graphing solutions. Then we talked about this. So we talked about the fact that the lines for us right now in the next, not the next section, but the section after that, it's going to be important that you get y by itself. So we talked about the fact that it's easy to graph if y is already by itself. Here, y is not by itself. So we said last class period that you may want to get y by itself. And this is not difficult to do because what's the coefficient of y here? 1. So to get y by itself, you're going to subtract 2x from both sides. Remember that? Okay. Then this is 0 here, so I get y equals, and let's put the variable term first. Negative 2x plus 3. All right. What kind of equation is this? Linear equation in how many variables? 2. So is this a linear equation in 2 variables? How many solutions are there? An infinite number. How do you represent the graph? A line. The graph's going to be a line. All right. We use a t-table. We've been using a t-table. This is a t-table. Talked about that. So we just need how many points? 3. So we need to kind of pick 3 ordered pairs. What's an easy number to use for x? 0. If x is 0, I get, wherever we see the variable x, I plug in 0. I get y equals negative 2 times 0 plus 3. What's negative 2 times 0? 0 plus 3 is 3. So I found an ordered pair. I found a solution. And it is a solution because if I take x and y here, plug it back in the original, Always go back to the original because you could have messed up getting y by itself. Always go back to the original. Wherever you see an x, what do I plug in?
0.
Wherever you see a y, what do I plug in? 3. Let's check and see if this is a solution. What's 2 times 0?
0.
And what's 0 plus 3?
3.
And is 3 equal to 3?
Yeah.
So it's a solution. Give me another number for x.
1.
2, 1, doesn't matter. Let's pick 2. If x is 2, I get y equals negative 2 times 2 plus 3. What's negative 2 times 2? And what's negative 4 plus 3? Negative 1. So I found another solution, another ordered pair that's on the graph. Now remember, to graph a line, you just need 2 points, but we're going to use 3 because I could have messed up with one of these points. Okay? And you can check yourself. And now on the test, you're not going to have time to keep checking yourself. But where we see an x, what do you plug in?
2.
Where we see a y, what do you plug in? Okay. What's 2 times 2?
4.
What's 4 plus a negative 1?
3.
3, and is 3 equal to 3? So that's a solution. So I did not make an error right here. I need one more point.
4.
Okay? If x is 4, I get y equals negative 2 times 4 plus 3. Negative 2 times 4? Negative 8 plus 3? Negative 5. All right, and so I applied those points. Now remember, how many solutions have I found? 3. How many solutions am I supposed to have? An infinite number. How do I represent those solutions? On a line. Okay, so 0, 3, you start the origin. All right, so remember, just have this in front of you. 0, 3, 2, negative 1, 4, negative 5. So 0, 3, since x is 0, I stay here at the origin, and y is positive 3, so go up 3. If it says label, what are you supposed to do? Yes, and remember, when denoting a point, you use parentheses, and don't confuse that with an interval, like we did with inequalities. Those were intervals. This is not an interval, this is a point. Then we do the point 2, negative 1. X is 2, y is negative 1. So there's the point 2, negative 1. I go to the right 2, down 1. And then the point 4, negative 5, the ordered pair 4, negative 5. 4, negative 5. And what quadrant is this point in?
4.
Quadrant 4. All these points better lie on the same line. They have to be collinear, and they are. So if you take a ruler and draw your line. Okay, make sure you extend it. Don't draw the arrow on this little dot here. Some students do that, and I'll take off a point. I want you to extend it. All right. And remember, you have to have arrows, because if you don't have arrows, remember from high school geometry what that represents. If there's no arrows, it represents a segment, an ending and a beginning. But this is a line that keeps on going, so you have to have arrows there. Make sure you draw arrows. All right. Then let's suppose you had this. Suppose you had x equal 4x minus, I'm sorry, 4y. That 4y. 4y. 4y minus 5. Do a t-table again. Now remember, what variable is by itself? X. So in the previous two, we chose numbers for x and then solved for y, right? Here we're going to choose numbers for y and solve for x, because x is by itself. So when I do the t-table, when I put in numbers, I'm going to put in numbers for y. So give me a number, give me a, and let's use integers. Give me an integer for y.
3.
3? All right, so if x is 3, I'm sorry, if y is 3, I get x equal 4 times 3 minus 5. 12 minus 5 is Use your calculator if you know what 12 minus 5 is. 7, right? So I'll plot the point 7, 3. Now remember, when doing your worksheet, whatever the coordinate plane looks like, just make sure that whatever point you choose here fits in that plane. So don't go beyond what's there, because then you're estimating where it's located. All right, give me another number for y. -3. I wouldn't choose -3 because watch. If you choose -3, look what's going to happen. I got x equal 4 times -3 minus 5. What's 4 times -3? -12. And what's -12 minus 5? -17, which is beyond this plane. All right, so don't use that one. So give me another number for x. For y. 2. Okay. If y is 2, I get x equal 4 times 2 minus 5. So that's 8 minus 5, which is 3. So then 3, 2 is in that plane. Give me one more number. 1. When y is 1, I get x equal 4 times 1 minus 5. 4 minus 5 is a -1. All right, so I plot those 3 points. And when I do that, now remember, on this D table right here, how many solutions have I indicated? 4. How many solutions are there? And a number. So we indicate the solutions using a line. So 7, 3 is in the first quadrant, so I go to the right 7, up 3, right? So there's the point 7, 3. 3, 2, I go to the right 3, up 2. And then -1, 1, I go to the left 1, since x is negative. And then up 1, since y is positive. See, if I went down 1, then you would notice it's not collinear. So you can always determine if you're plotting the points correctly. Some students get confused with plotting points still. So it's -1, +1. And so, again, label so you get something that looks, all right, it didn't actually exactly go through, but that's fine. And don't forget to draw your arrows.
So, Mr. President, with these problems, so we're just throwing out random numbers?
Yes.
Okay.
Yep.
So really there's no right or wrong answer on a technicality because...
Well, you got to make sure that whatever number you pick here, when you plug it in, your whatever value you get here is correct, though. You can't just...
Right, that.
Yeah. Yeah.
Okay.
I could have chosen any number for y, since x was by itself. I could have chosen -100, -2000.1, and anything. All right, but I wouldn't choose those because then it's outside the range, and I wouldn't choose a decimal because then you would be approximating.
Okay.
Yeah, but yeah, you could choose a number for x or y, and just plug it back in, find the other value. Yeah. All right, then we start talking about this. All right, here's the question. Is this a linear equation?
Yeah.
Yes.
Y-Intercept.
Okay, very good. Now what she means by that is that this is still a linear equation in 2 variables. So if I were to graph this, it would still be a line. And you don't see the other variable y, but we talked about the fact that I can rewrite this as x plus 0y equals 6, because 0y is 0. 0 times y is 0, right? And x plus 0 is still x. So this is still linear. All right, so that is a linear equation. So on one of the worksheets, you're given a table, you're given some equations, you have to determine if it's linear or not. So last class period, and you need to look at the notes, the last class period, we gave examples about what are linear equations and examples about what are not linear equations. And use that to help you on that worksheet. So this is linear. Now, if one of the variables is missing, in this case y, do you remember what kind of line this is? All right, you don't. And that's okay, but make sure you know it for the test. So here's what we said. What is x?
6.
Can x be anything else?
No.
No, x has to be what? 6. That's what that says. X is always equal to 6. So if you recall, mentally, think about this. If you recall, what I did was I drew a t-table, and I said this. X is always equal to what? That's what I said. And so that means that along this x column, I'm always going to have what?
6.
Nothing else. Because this says x has to be what?
6.
No matter what y is. So y could be anything. If x is 6, y can be what? 2. If x is 6, y can be what? 10. If x is 6, y can be what? Okay, let's use some negatives. Negative 2. If x is 6, y can be negative 6, 0, and so on, right? Even some decimals, even some fractions. So when the variable, when the variables, there's only one variable there, you got to remember, in this case, that x equals 6 means that your x column is always 6, because that's what it says. X has to be 6, nothing else. But if I plot this, which the question earlier was, do you remember what kind of equation this is, or what kind of line this is actually? None of you were able to tell me. But if I plot those points, you should then be able to tell me. 6, 2 is here. 6, 10 is here. 6, negative 2 is here. What kind of line is this? They're all vertical, but I need you to say what word. I'm sorry, they're all lines, but they're all straight. But I prefer what word? Vertical. So x equal a number is a vertical line.
So why did the point go over where the negative 2 side was?
Say it again.
For the negative, for the 6 and I think it's negative 2.
Okay.
We have the negative 2 beneath the 6, but I'm thinking that last point isn't on the side where negative 2 is because
Okay. So here's how we plot a point. You start at the origin.
Okay.
I start here. What's my x value? I go to the right, 6. What's my y value? No, my y value is not 6. My y value is negative 2. So I go down 2. So there's the point 6, negative 2. Okay? All right. Then we talked about this.
So is it safe to say that if all numbers on the x-axis are 6, it's always going to be a vertical? And then if they're all the same on the y, then
It's be horizontal. Yep. So if I have y minus 3 equals 0, okay, y minus 3 equals 0. What kind of equation is this? Linear. And right, so 0 would be the coefficient of x. They used to use the phrase 0 represents x. That's not true. The coefficient of x is 0. That's the better phrase to use. But using what we discussed earlier, what might you want to do first? No, there's no x there. Get y by itself. So I'm going to add 3 to both sides. So then I get y equals what? 3. Now that kind of looks like the one we just did. So in terms of a t-table, what does this represent? Y is always 3. So along the y column, I'm always going to have a 3. That's what that represents. no matter what x is. So if y is 3, x can be what? 2. If y is 3, x can be what? Negative 4. If y is 3, x can be what? 0, and so on. All right? When it comes time for a test, most students can graph a linear equation that they actually see two variables. But with one variable, they just get thrown off, which should be the easier kind. But given this graph, many students don't know what to do with it, even on a test. So you really need to get those points. So y equal 3, yes.
So when you were saying, I'm sorry, I was sick Tuesday.
Okay,
so
go
I'm
ahead.
kind of
That's fine.
Out of it. So when you're saying like x is always 6 and y is always 3, you're just saying for this problem, not like.
Well, of course, yeah, for this problem.
I was trying to understand where that was coming from.
We're graphing this equation.
For this.
Okay?
Okay.
That means for every equation, y is always going to be that.
Okay.
Okay. All right. So let's plot those points. 2, 3. I go to the right 2, up 3. Now, guys, remember you got to know how to plot points. Some students, very few, for that 2, 3, this is what they'll do. They'll put a dot on 2 and a dot on 3. That's not what you do. Okay? So you need to know how to plot a point. All right. So you go to the right 2, up 3. Negative 4, 3. Since x is negative, I go to the left 4, and then what? Up 3. And what do you notice about that line? It's horizontal. So y equal 3, y equal a number is what kind of line? Horizontal. Okay, so y equal a number is a horizontal line. So this is the equation y equal 3. All right. So the equation we grabbed, the linear equation we grabbed, some of them rose, some fell, some were horizontal, and some were what? Vertical. Okay. That all has to do with slope, which is going to be one of the sections in a little while.
Is that gonna be on the final?
Yeah. And you need to know that for college algebra.
Thing is just like Portuguese to me. I do.
And it could be Chinese for somebody else.
Right.
But you learn the language. But you learn the language.
That's what
You got to assimilate with
I'm
what you have.
really trying.
Okay? Hey, for Olivia, it could be Mexican, but she can learn it. Okay? You can learn it. It's what you put into it. Okay.
I'm putting blood, sweat, and tears. If you need, you're gonna try.
Then I'll be charged for murder. And I'll be fine. I'll be in prison for a long time.
That's fine. You can teach math in prison. You can teach math in prison.
Yeah, yeah. And then Helen can come and I'll teach her.
And I'll be in my grave.
Okay, let's continue on. All right. But guys, you remember it could be whatever language you think it is now, but it's what you put into it.
And don't they say math is the universal language?
That's right. That is correct. But it's what you put into it. All right, Erica. Let's continue on. All right. So let's see. All right. I have not given you a worksheet where you had to graph horizontal and vertical lines. I haven't done that yet. So all the worksheets you were given were linear equations where the lines were either rising or they were falling. The next class period, I'll give you those worksheets where some are horizontal and some are vertical. Okay? All right. Now, Let's look at this. Section 10.3. I'm going to draw my two axes. So here's your x-axis, here's your y-axis. And one of the things that you're going to do next semester is you're going to graph a quadratic equation. And the graph of a quadratic equation is a parabola, looks something like this. Right. And then we get to college algebra, you're going to be graphing all kinds of functions. And you don't know what a function is, but you'll be graphing all kinds of functions. In here, the only functions that you can be graphing for the most part are lines. All right, now, wherever a graph crosses the x-axis, and how many places does this graph cross the x-axis? 2. Wherever a graph crosses the x-axis, those are called X-Intercepts. Okay, X-Intercepts. So an X-Intercept is where the graph does what? Cross the x-axis. All right, now, so what do you think this right here would be called? The Y-intercept. Because that's where the graph crosses the y-axis. Okay? So when you get the worksheet, that Part A worksheet in this section, it's really not difficult. You're going to be given a graph. I'm going to ask you to find the X and Y-intercepts. Okay. X and Y-intercepts. And draw this. So you have your X and Y axis. And let's suppose that you had a graph that looked like this. Now, you're going to see something like this in college algebra. So that will be a cubic equation. When you get to college algebra, you have to graph this. And let's suppose that this is -1, this is -2, this is -3, -4, and so on. Here's 1, here's 2, here's 3, 4, 5, and so on. I'm making this up. 1, 2, 3, 4, 5. All right, -1, -2, -3. All right, so just draw those. All right, I want to find the X and Y intercepts. How many X intercepts does this graph have? 3, because it crosses the x-axis how many times? 3. So that was an easy question for you. How many Y-intercepts does this graph have? 1, because it crosses the y-axis how many times? 1. So that was easy. All of you should have been able to answer that. The other thing you can answer to me is this. What are the x-coordinates for the X-intercept? Where does the graph cross the x-axis? Let's start from left to right. -3, good. 2, good. And 5. Those are your x-coordinates for the intercepts, the X-intercepts. Okay? Where does the graph cross the y-axis? At what point? 3. When y is what? 3. All right. So that was not difficult. But here's what's going to get you. Find the X and Y-intercepts. Write the answer as an ordered pair. Okay? Write the answer as an ordered pair. So the way it's going to look on the worksheet is this. It's going to say X-intercepts. And then Y-intercepts. And I use the plural, but there's only one, the Y-intercept. When the answer is written as an ordered pair. So an ordered pair means you got to have an X and a Y. All right, now, we talked about this last class period. Wherever you are on the x-axis, what is the y-coordinate?
0.
Very good. Y-coordinate is 0. Wherever you are on the y-axis, what is the x-coordinate? 0. So if I put a little dot here, right here, and then I ask you, what is the x and y coordinate of that point? What's the x-coordinate?
0.
No.
Negative.
Yeah, -3, right? What is the y-coordinate? 0. Because remember, you started the origin, I went to the left 3, and I stayed, right? I go to the left 3, that means my x-coordinate is what? Went to the left, -3. I stopped, I didn't go up or down, so my y value is 0. What are the coordinates of this point? 2, 0. What are the coordinates of this point? 5, 0. So those are ordered pairs. So don't just put -3, 2, and 5 if the direction says write as an ordered pair. Okay? So if it says write as an ordered pair, you're supposed to say -3, 0. What else? 2, 0, and then what? 5, 0?
If it asks for an ordered pair and it's not on one.
Well, then that would not be an X-intercept or a Y-intercept.
Okay, so
It's got to intersect the x-axis. That's the definition of X-intercept, where it crosses the x-axis. What is a Y-intercept then? Be careful where you put the 0. 0, 3. Because remember, here's the point, right? And so to get to that point, you start the origin. I don't go left, right. I stay there. So that means x is what? 0. And then I go where? Up 3. So that means y is 3. Okay?
So y to 0 is going to be first and x is
Ordered pair. X, y. X is first, y is second. Okay? So just like the t-table, when I did the t-table, what variable was listed first? X. What was listed second? Y. That's how we do the t-table. X first, y second. Corresponds to an ordered pair. X coordinate, y coordinate. All right, so the point you got to get from here is this. The X-intercept is where the graph crosses the x-axis. The Y-intercept is where the graph crosses the y-axis. Okay? The other thing you got to remember is that any point on this graph is called a what? Solution. Okay? How many solutions are there? An infinite number. How many X-intercepts are there? 3. How many Y-intercepts are there? 1. Okay. Is this a solution right here? No, not a solution. Would that be an X-intercept or Y-intercept? No, because it doesn't touch the x-axis or touch the what? Y-axis. Okay? All right. The other thing you got to take from here is that whenever you're looking at the x-intercepts, your y-coordinate is always what? 0. Whenever you're looking at the y-intercept, the x-coordinate is always 0. Students, when they don't really fully understand that idea, they get these coordinates mixed up. They always seem to think that the y-intercept, y is 0. It's not. X is 0. Okay? Which takes us to this. Listen carefully. Let's talk about this again. If I look at this line, right here, and I ask you to tell me what is the coordinate of this point right here. Right here. What are you going to say? -2, 0. Right? No matter where I am, wherever I draw this line, no matter where I draw this line, if I look at all these x-intercepts, what is the y-coordinate every time? 0. No matter where you are, the y-coordinate is 0. So when you find the y-coordinate, given the equation, when you find the y-coordinate, I'm sorry, when you find the X-intercept, excuse me, when you find the X-intercept, you're going to let y be 0. So to find the X-intercept, you're going to let y equal 0. Because no matter where you are on the x-axis, what is the y-coordinate? 0. Let's talk about the y-intercept right here. Let's say this is 1, this is 2, and this is 3, and so on. So if I ask you to tell me the coordinates of this point here, what are you going to say? 0, 3. And in fact, no matter where I am on this y-axis, what is the x-coordinate always? It's always 0, because remember, to label a point, you start at the origin, and all these points are below it, right? Or above it. So that means I stayed at the origins. That means x is what? 0. So no matter where I am on the y-axis, x is always 0. So to find the y-intercept, you're going to let x equal 0. To find the y-intercept, you let x equal 0. All right, so to find the x-intercept, you let y equal 0. To find the y-intercept, you let x equal 0. So we're going to start out with a simple one. And let's suppose we had this. Now, you remember, always follow the directions. So, for example, in the final, they'll usually say, graph this line using intercepts. You must use intercepts if it says that. All right, so you always follow directions. Okay, so graph 2x plus y equal 4, negative 4, let's make it negative 4, using intercepts. Okay, so graph 2x plus y equal negative 4 using intercepts. Now watch how simple this is. So here's what you're going to say. So now remember, before when we graph all these other lines, how many points did we plot? 3. How many points do I plot here? 1, 2. Because there's a x-intercept and a what? Y-intercept. Remember, this is a line. These are lines. So to find the x-intercept, I'm going to let what? Y equals 0. So if y is 0, wherever you see a y, what do I plug in? 0. So look, 2x plus y, what is y? Equal negative 4. But what is 2x plus 0? 2x. And how to get x by itself? Divide by 2, and I found the x-intercept. The x-intercept is negative 2. That's the x-intercept. As an ordered pair, now guys, on my math lab, some of them will say ordered pair, some of them will say just what's the x-intercept. So if you said the x-intercept is negative 2, that's fine. It's negative 2. If they say rise in ordered pair, you have to say what? Negative 2, 0. Good. Okay, as an ordered pair. So that's where the graph's going to cross the x-axis. So notice what you did. To find the x-intercept, wherever you saw the y, you plugged in what? 0. So you're done. You just need one more point. And it's going to be the which intercept? I found the x. Which intercept do I need to find now? The y. All right. So here's what you say. You say to find the y-intercept, you're going to let x equals 0. So this time, wherever you see the variable x, what do you plug in? 0. All right. So I say 2 times 0 plus y equal negative 4. What's 2 times 0? And what's 0 plus y? No, what's 0 plus y? Not 2y. It's just y, right? 0 plus y is y. So what's my y-intercept? -4. What is that as an ordered pair? 0, -4. So 0, -4. So you found the intercepts. Now you graph it. All right, now watch. Remember, the intercepts must be on the axis, right? No other place. Cannot be, do not put the intercepts in a quadrant, because those are intercepts. That's where the graph crosses the axes. So for this one, and this is going to be 2x plus y equal -4. So let's plot the x-intercept. So the x-intercept is -2, 0. So I start the origin, and -2 tells me to go where? To the left, -2. 0 tells me to do what? Stay. So there's the x-intercept. Now let's do the y-intercept. What's the y-intercept? It was 0, -4. So 0 tells me to do what? Stay. -4 tells me to do what? Go down 4. All right, now if it says label, you got to label. So this is -2, 0, and this is 0, -4, and you just graph your line, and you're done. All right, so there's your line. It's very simple for this case to find the x and y-intercept. To find the x-intercept, you let what be 0? You let y be 0. To find the y-intercept, you let what be 0? X. And that's it. That's all you do. Remember, you always follow the directions. So the direction says use a t-table using 3 points. You do what we did in the previous section. If it says graph the line using intercepts, then you do this. So you got to follow the directions. All right, now let's look at this problem. All right, suppose we had this. All right, so let's graph. 3x minus 2y equal 6. 3x minus 2y equal 6. Using intercepts. Using intercepts. All right, remember this is a line. This is a linear equation. So we're going to find the x and y-intercept. All right, to find the x-intercept, what do? At y equals 0. So where we see the variable y, you're going to plug in 0. So I get 3x minus 2 times what? 0 equals 6. What's 2 times 0? And what's 3x minus 0? 3x. So I get 3x equal what? 6. Now how to get x by itself? Divide both sides by 3, and I found the x-intercept. The x-intercept occurs when x is what? If you need your calculator, use your calculator. 6 divided by 3 is 2. So when x is 2. As an ordered pair, what is that? 2, 0. And it kind of makes sense because what am I saying y is here? 0. So you better have 0 for y. To find the y-intercept, what do? At x equals 0. So where we see the variable x, what are you going to plug in? 0. So I have 3 times what? 0 minus 2y equal 6. What's 3 times 0? All right, now listen carefully. What's 0 minus 2y? Negative 2y, good. And then how to get y by itself? Yep. So what is the y-intercept? Where does the graph cross the y-axis? At -3. That's where the graph crosses the y-axis. What is that as an ordered pair? Yeah, because you know that x has to be 0 because that's how you found the y. You let x be 0. All right, and then you plot those 2 points, and there's your graph. That's all you do. It's not difficult to find the x and y intercepts. So 2, 0 is here. This is 2, 0. 2, 0. And then 0, negative 3, you stay there, and then you go down 3. And then you just draw your line. Okay? Don't forget to draw the line. On a test, you get stressed out and you forget to draw your line. You plot the points and that's it. But remember, all you did was just plotted the 2 points, but you haven't graphed the equation. The equation is a line. And that's all you do. You're done. That's all this is. All right, now, let's look at this one. So this was 3x minus 2y equals 6. Okay, let's look at this equation. Suppose you had this. All right, suppose you had this. Now on my math lab, this is the way it's going to look on my math lab. It's going to say this. So you got to be careful with what I'm about to tell you. Or you need to listen to what I'm about to tell you, because in my math lab, you're not going to know what to do with the directions it tells you. It's going to say this. It's going to say graph. Let's say you had x equal 2y. Graph x equal 2y using intercepts. Okay? All right, now, there's something else to this directions, but I'm going to leave it like that for right now, just so we can have that little discussion. All right, to find the x-intercept, what do? You let y equals 0. To find the y-intercept, what do? All right, let's do that. So let's see what happens. To find the x-intercept, you let y equals 0. So if I let y equals 0, I get x equal 2 times 0, right? So I found the x-intercept. The x-intercept is going to be where x is what? 0. As an ordered pair, what is that? 0, 0. 0, 0 is the what, though? The origin, okay? To find the y-intercept, you let x equals 0, right? So if x is 0, I get 0 equals 2y. And then how I get y by itself? Divide by 2. And so 2 divided by 2 is 1. 1 times y is y. And what's 0 divided by 2? Y is 0. As an ordered pair, what is that? All right. Now, if you go back to the problems we just did, the x and y intercepts were distinct points. You know what distinct means, right? They're not the same point. What do you know about these x and y intercepts? They're the same points. So when I plot those x and y intercepts, I get this. But to graph a line, how many points do I need? 2. That's only 1 point. So the direction is going to say this. It's going to say this for this kind. So notice why the x and y intercepts were the same. In all the problems we had, you had the 2 variables and a constant, right? Meaning this. 3x minus 2y, and you had the constant what? 6. 2x and y, and you had the constant negative 4, and so on. So that's why the x and y intercepts were distinct. Here, though, that constant's 0. There's no constant there. It's understood to be 0. X equal 2y plus 0. Right? So that's why the x and y intercepts are the same. That's the origin. So the rest is going to say this. Graph x equal 2y using intercepts. If the intercepts are the same, plot another point to graph. Say again? Yeah. Well, not any point. You got to make sure it satisfies that equation. Yeah,
Right.
so what you would then do, what I would then do is I draw a t-table, do a t-table, and notice, guys, that what letters by itself? X. So pick a point for y. So give me a value for y. 2, okay? If y is 2, I get x equals 2 times 2, which is what? And so I found the other point. So another point of that line would be what? Right here. Another point of the line would be what? 4, 2. So I go to the right 4, up 2, and I found another point. So you just draw the line now.
Did you just choose the number 4 randomly?
No, I didn't choose a number 4 randomly. I chose 2 randomly. And that plugged in for x. 2 times 2 is 4. Okay? So someone else could have chosen what number for y? Huh? 3. I would have said x equal 2 times 3, which is what? 6. And it didn't matter because it would still be collinear. It didn't matter which one I chose because look, 6, 3 still lies in the same line, doesn't it? Someone else could have chosen what value for y? 5, -1, right? If y is -1, I would get x equal 2 times -1, which is a -2. So then I'll plot the point -2, -1.
So what's it gonna be asking you for though, like? what is
Find
it-
x graph using intercepts.
But we're gonna come up with our own number, let's say 2, right? So then x is gonna be 4. So.
Yes.
Okay, is it gonna be a fill in the blank, like?
No.
How is it gonna be?
When you get to that, it's going to be a tool. You're going to have to use that tool to kind of plot the other point, and it'll automatically draw a line. Yeah. So it's an online. Remember, My Math Lab is online. So on paper, this is what you would draw.
Is it gonna
When you
be-
get there, hold on. When you get there, you're going to click on the thing that looks like a graph, and then you plot the origin because that's the intercept. Then you plot another point. In this case, it would be 4, 2, and it automatically draws a line.
Are you gonna write that out then, 4 and 2, or you're just gonna plot the dot?
No, you're going to plot the point 4, 2. You're gonna put the cursor on 4, 2, and it'll automatically draw the line. All right.
And
Yeah.
it knows if it's wrong, like if you put something.
Yeah. If you put the wrong point, it will say it's wrong. Yeah. Yeah. So when you get to that point and you haven't done anything so far, even if you took 97 last semester, which you didn't have graphs in it, this is the first time in your experience you're going to be graphing online. So it's a tool. You're going to click on the cursor and draw the line. I'll try and kind of get to one of them and show you what it looks like. But I'm glad you brought it up because I forgot that you haven't done anything with that tool. But on paper, though, and on the test and on the final, it's not online. You're just going to have to do this. Okay, that's what you have to do. Okay? And that's all this is for in terms of intercepts. So it's not that difficult, really. To find the X-intercept, you let y be 0. To find the Y-intercept, you let x be 0. So let me just kind of real quickly show you that tool so you're not confused as to how to graph.